All right, welcome everybody. Let's do this. Lesson 15, end behavior of polynomials. What does end behavior mean? We'll talk about it very soon. So, what I'd like you to do is take your calculator, reset it, and let's put these functions into the calculator and see what it looks like. All right, and if you're forgetting how to reset, remember second plus 712, so I'll do that. We'll go second plus 712, and bam. Calculator is reset. So we go to y equals, and let's plug in these functions and see what happens. You see here, x squared, we should be all okay with what x squared looks like, but what happens when we have x to the fourth, x to the sixth? How will the graph change? So let's see, x, and remember if you want to put to the 4, you put this little caret symbol over here, so hit to the 4. Okay, and let's go to the next one, x to the 6. Okay, and let's hit graph. And notice this is x squared. The next one will be x to the 4th, and then the next one will be x to the 6th. So notice that, let's draw these over here very quickly. So the blue one is this. So this is x squared. Let me draw it right here. This is x squared. Okay, what's the next one in red? Or it doesn't even matter. This could be x to the 4th. And then the next one will be x to the 6th. Okay, so this is x to the 6th. This is x squared. And then this one will be x to the 4th. Okay, now you could say, oh, Mr. G, let's take a look at this. And notice, oh, hey, like, if this is x squared, right? What happens with x to the 4th? It gets more narrow, and x to the 6th even gets even more narrow, okay? But that idea is not what we want to focus on today. What we want to focus on today is end behavior of graphs, okay? And what does that mean, end behavior of graphs? The question we want to ask is, what is happening when x is going to positive infinity, or when x is going to negative infinity? So let's take a look at what on earth do I mean over here. Let's ask yourself this, and this I want you to copy down in your notes, okay? So let's just look just at the x squared, right? This question is saying, let me fix the camera angle a little bit. Okay, ask yourself, as x is going to positive infinity, and what do we mean by that? Let's take a look at this. Here, this is your x, right? So imagine x is going to positive infinity, right? This is like x equals 1, x equals 2, x equals 3. X is going all the way to positive infinity, okay? It's saying when x is going to positive infinity, the question you want to ask is, where is f of x going? And when we talk about f of x, we're talking about the graph. So where is the graph going? Where is the graph going? Okay, well, let's take a look. You see, as x is going to positive infinity, what's happening to the graph? This is going to positive infinity. Okay, so that's what happens over here. As x is going to positive infinity, f of x is going to positive infinity. What about the next question, right? What's the next question we're going to ask ourselves? Ask yourself, as x goes to negative infinity, as x approaches negative infinity, where does the graph go? Well, let's take a look over here. If I take it, where is negative infinity for the x? When I'm going this way, where is the graph going? Is the graph going to positive infinity, or is the graph going to negative infinity? And the answer is pretty straightforward. It's just going to positive infinity, okay? What I want you to do is, I want you to do what we did over here, and I want you to ask yourself these questions as you try and do the next one. Try and graph this one by yourself, and try and answer these questions of, as x goes to positive infinity, where is the graph going? As x goes to negative infinity, where is the graph going? Try and do it by yourself. All right. Now, if you want to see, watch how I do it very quickly, let's just go to our calculator, right? And let's graph this. So predict what's going to happen. So y equals, I could just change this. Okay, so negative x squared. Let's see the next one. Negative x to the fourth. The next one, negative x to the sixth. Okay, and I hit graph. And notice what's going to be different when we have that negative. Notice that the graph flips, right? It flips over the x-axis. So if I wanted to draw these graphs, what are they going to look like? They just simply look something like this, right? All these graphs are going to look the same. One will be narrow, one will be more wide, but it doesn't matter. All we want to do is just look at the end behavior. That's the only thing we want to focus on. So let's ask ourselves this question. As x is going to positive infinity, right? Wait, let me get it over here. Here, as x is going to positive infinity, or as x approaches positive infinity, where is f of x approaching? So then let's just do that right here. Okay, so as x is going to positive infinity, so I'm going this way, where is my graph going? Is it going up or is it going down? Here, notice it's going to negative infinity, this arrow over here, okay? And what about the next one? So this is positive infinity for x. And what about here? As x is going to negative infinity, where is f of x going? This is going to negative infinity, okay? Now let's take a look at this. Hopefully this was okay. And not too bad. What I want you to do is, let's take a look at this, okay? If you see this paper that you have over here, right? What I want you to do is, we're gonna do the first two together over here, and then I want you to do this one by yourself. But here, let's take a look at this. If we look at this one over here, notice that these two graphs this correlates to this one, okay? So when we take a look at the degree over here, if you look at it, we have 2, 4, 6. These are what we call even numbers. So what does it mean to be an even number? Remember, even, you're 2, 4, 6, 8. So here, when the degree is even, and let's take a look at the leading coefficient. The leading coefficient is right here. Notice that the leading coefficient is positive, right? We have this end behavior. As x goes to positive infinity, where does f of x go, right? You see, as x goes to positive infinity, f of x goes to positive infinity. What about the next one? As x goes to negative infinity, right? F of x is going where? It's going to positive infinity, okay? And what are other examples of polynomials that do that? If you graph, for example, this, x squared plus 6x plus 8, you see, notice that the degree, you have to think about the definition. The degree of this polynomial is even. The leading coefficient is positive. If you have an even degree positive leading coefficient, your graph is going to look like this, and it's going to have this end behavior. What I want you to do is pause the video and try and do the next one by yourself over here. What will it be for this one? All right, try and do it by yourself. Okay. Now, if you want to see it done, notice what is the degree? 2, 4, 6. These are even numbers. What's the leading coefficient? Notice that this is negative. Okay, then what do? We say as x approaches positive infinity, right? As x is going to positive infinity, f of x is going to negative infinity, right? All right, what about the next one? As x goes to negative infinity, f of x goes to negative infinity, all right? What I want you to do is take your time and try and do the other one. You don't even need a calculator. just try and see, actually, I'm sorry, I take that back. Try and do this. Try and do this one, and try and do this one, and then fill in the graph. I mean, fill in the chart. Okay, I hope you enjoyed this.